So what is the physical meaning of this? Let us see that. So I have this argon plane. Okay, this is the real axis, this is the imaginary axis, and let us say this is the complex number. Okay, this is the complex number z. Okay, so what is the argument of this complex number z? What is the argument? The argument of this complex number is basically this angle, right? This angle. So if this is theta, let us say this is theta, then argument is basically reaching to that vector, reaching to this vector by rotating the positive real axis in counterclockwise direction. Then I will write positive plus sign with the number, with the argument, and if I rotate it clockwise direction, then I will write negative sign with the argument. Okay, so if I rotate real axis, positive real axis, if I rotate positive real axis about O, then I will have to rotate by an angle theta to reach this vector, correct? Similarly, I can rotate this positive real axis by not only by theta but by this angle also, right? By this angle also. And what is this? This is basically theta plus 2 pi. No? Similarly, I can rotate this positive real axis. No, I can rotate this positive real axis by this angle, this angle, and then also I will reach the vector represented by this complex number, and this angle will be nothing but theta plus 2 into 2 pi, right? So similarly, I can add 2 pi to that argument, that is just one adding one circle, so that will not make any difference to the measurement of theta. I will still reach to this line, right? So basically I have to reach this line by rotating this real axis, and the number that I will get, the angle that I will get, will be the argument. Okay, similarly I can rotate this in clockwise direction, and the angle I will rotate by theta minus 2 pi, theta minus 2 pi, theta minus 4 pi, theta minus 6 pi. So in general, if I write argument theta, then theta plus 2k pi becomes the argument, no, where k is a integer. K is an integer. It can be a positive integer or it can be a negative integer. Positive integer means I am traversing in counterclockwise direction, and negative integer means I am traversing in clockwise direction, but I am still reaching the same line. That is understood, right? But so this is the general argument, but there is something called principal argument. There is something called principal argument. I will write in short. So the principal argument is basically, if I measure the argument in such a way that, let us say this is the complex number, this is the complex number. So if I measure the argument in such a way that I do not cross the real axis. So let us say if I have to reach here, then I will rotate this way. Let us say the complex number is somewhere here, here. Okay, so if the complex number is somewhere here, then I will rotate this much angle. Let us say the complex number is somewhere here, here. Okay, so I will, or let us say the complex number is somewhere here, 4 complex numbers. Okay, so if this is the complex number, no, So let us say this is this is Z1, this is Z2, this is Z3, this is Z4. Okay. So if I have to measure Z1 and Z2, then I will rotate positive real axis in counterclockwise direction. So I will reach here, I will reach here. Let us say this is theta 1, this is theta 2. But if I have to measure the argument of Z3, then I will not measure in counterclockwise direction because I don't have to cross the real axis. So how will I measure? I will measure it in this way. Similarly for Z4, I will measure into this way. So all the complex number lying on the first and second quadrant will have argument starting from 0 to 180 degree, right? 0 to pi radian, and all the complex number starting all the complex number lying in third and fourth quadrant will have their argument represented in negative way. So this is 0 to minus 180 degree, and if I measure in this way, then the argument will be called the principal argument. Then the argument will be called principal argument. So if I say if theta is principal argument, then theta should obey this inequality, which is theta should be less than or equal to pi or greater than, I will say equal sign here, minus pi, or theta belongs to minus pi to pi in this interval. So then if I represent theta this way, then theta is called principal argument. So principal argument cannot have 2k pi added to it, because I cannot complete the full circle, right? I mean, in first and second quadrant I will measure only in 0 to 180 degree. In the third and fourth quadrant I will measure in minus direction. So this will have minus, let us say if this angle is theta 3, then argument of Z3 will become minus theta 3, right? And if this angle is theta 4, then argument of complex number Z4 will become minus theta 4. Okay, we will see it in more detail. Now let us take some examples of I, powers of I. Okay, so let us solve one example. Yeah, so example 1, I want to solve this, or I want to simplify this question. I to the power, let us say n plus 100 plus I to the power n plus 50 plus I to the power n plus 48 plus I to the power n plus 46, right? So what is the first step? What is the first uh, step I will take? I can take I to the power n common, so I will be left with I to the power 100 plus I to the power 50 plus I to the power 48 plus I to the power 46. No, then I to the power n, I'll keep it like this only. I to the power 100, I can write I to the power 4 to the power 25. No, this I can write I to the power 4. Why I am writing it into powers of 4? Because I know that I to the power 4 is 1. Okay, so I to the power 4, I can straight away write 1, and whatever is remaining, and then I will see whether it is I cube or I square or I. Okay, this I can write I to the power 4 to the power 12, then 12 into 4 becomes 48. So how many i's are remaining? 2. So I can write I square plus 48 I to the power 4 to the power 12. Okay, plus I to the power 4 to the power 11. So 11 into 4 is 44, and how many are remaining? Into I square, 2 powers. Or in fact I could have taken I to the power 46 again common out of all this, and that could have been another simplification, but that is also okay. This is equal to I to the power n. So this becomes 1 to the power 25. I can straight away write 1, no, plus this becomes I to the power 4, that is 1. 1 to the power 12 is 1, so I am left with I square, no, this is again 1 to the power 12, so becomes 1. This is 1 to the power 11, 1 into I square, so last term is I square, no, so I to the power n 1, I square is minus 1, plus 1, I square is minus 1, and this is giving me 0. So answer of this example 1 is 0. So if I simplify this expression, I will get 0. So it is a simple question, right? You can try it once again and let me know if you have any doubt. Okay, let me take another example. Okay, I want to find the value of this summation n is equal to 1 to 13 I to the power n plus I to the power n plus 1. Okay, this is the summation for which I want to find the answer. I is of course the iota. In exam you might get where I is root to the power minus 1. So they usually make sure that I is the iota. So there are so many ways I can tackle this problem. um, I can in fact divide this summation over this term and this term and solve separately, or I can combine this in the same notation of summation and solve this. So I will take it this way. I will take sigma n is equal to 1 to 13 as it is, and I will take I to the power n common. I am left with 1 here and I here, right? So 1 plus I. So this term 1 plus I, this term is independent of n, so I can take it out. No, I can simply take it out. So 1 plus I summation n to the power 1 13 I to the power n. Okay, now if I expand this, 1 plus I will remain as it is. If I expand this summation, then I will put 1 in place of n, plus I will put next integer, that is 2, in place of n, plus then I will put next integer 3, 4, 5, 6 like that, and I will keep on going till I get n is equal to 13. So I will get here I plus I square plus I cube plus I to the power 4 plus dot 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 up to I to the power 12 plus I to the power 13, up to 13, no? And now we will recall one finding that we derived in previous section, that sum of 4 consecutive powers of I, sum of 4 consecutive powers of I is 0. Integral power, of course. So for example, I can have I to the power 526 plus I to the power 527 plus I to the power 528 plus I to the power 529, and that will give me 0. Why? Because sum of 4 consecutive integral powers of I is 0. So that finding I am going to apply here. I can group this summation into group of 4 terms, group of 4 terms, right? Consecutive 4 terms. How many terms are there? 13. 1 to 13. 13. So how many groups of 4 I can make? 3 groups. So I can write here 1 plus I, and I can start from the beginning or I can start from the end, whatever. So I will take I plus, and then I will left with first group, group 1 plus group 2 plus group 3, no, 3 groups, where each group is having summation of 4 consecutive powers of I, and that I can straight away put to 0. No? So I am left with only I. So 1 plus I into I, and if I multiply I, then I will get I plus I square, and we have seen I square is -1, so the answer becomes I minus 1. So that's a simple question, right? So same way we can solve a little more difficult problem. Probably I can give you an assignment wherein some more questions on powers of I will be there, and you can solve it. Okay, and okay, so before I end this lecture, let me um, take few complex numbers and find their argument, find their magnitude, and find their principal argument. Okay, so I will just recall. I have already in fact done. So if the complex number is I, what is the magnitude of it? Magnitude of it I can find in several ways. I can say root of x square plus y square, that means root of real part of complex number is square plus imaginary part of complex number is square, and then find what is the value. Or I can use the representation in argon plane and find out where is this line in the argon plane, and then I will see how far is that point from the origin, and that will give me the magnitude. Then I will find the argument, and if the complex number is given in Cartesian form, then I will write its polar representation, polar form, and I will see at the last what is the principal argument. Okay, so what is the magnitude of I? I is lying. What is the real part of I? This I can write as 0 plus I into 1. No, so real part becomes 0 and imaginary part becomes 1. That means 1 unit on the 1 unit here. No, 1 unit here. So this is 1 unit. So this complex number is represented by I. No, so what is the magnitude? Magnitude is the distance of that point from the origin, which is 1. Okay, what is the argument? The vector joining that complex number, the angle of that vector from positive real axis. So this is the argument. No, so how much is this? Pi by 2. So pi by 2. What is the polar form? Polar form is simply magnitude r into cis theta. Theta is the argument. So what is r for I is 1 cis pi by 2. And what is the principal argument? Principal argument is also pi by 2. Correct. Similarly, let me just erase it. What about -1? Its magnitude is 1. Okay, its argument is pi, its polar form is 1 cis pi, and its principal argument is also pi. Usually we don't define principal argument when the complex number is lying on the real axis, but this is special case. I can write pi or I can write minus pi as well. I will reach to the same location. Let me take this complex number 1 plus I. So what is the magnitude of 1 plus I? 1 plus I means 1 unit in the real axis, 1 unit in the imaginary axis, no, and whatever complex number I will whatever vector I will make, the length of that vector or the distance of that point from the origin will be the magnitude. So if this is 1, this is 1, what is the magnitude? Root 2, right? Simple right angle triangle Pythagoras hypotenuse formula. I can get magnitude as root 2. What is the argument? If you calculate this angle alpha, this will be pi by 4. What is the polar form of this? Root 2 cis pi by 4. And what is the principal argument? Is pi by 4. Okay. Now let us add little more difficulty to this problem. I will have 1 minus I. This is the complex number. So where is 1 minus I? 1 minus I, right? So 1 in the real axis and minus 1 in the negative axis, negative imaginary axis. So minus 1. So I will join this. No, this is the real axis, this is the imaginary axis, this is origin. So what is the magnitude? Magnitude is the length of this vector. This is 1, and of course in the negative direction, but the length is 1. So the magnitude will become root 2. And what is the argument now? Just see, now I am measuring this in clockwise direction. This is the clockwise direction. So even though this angle is pi by 4, but I will write argument as minus pi by 4. Or if you want to write it in positive direction, you can very well write the value of this angle, and the value of this angle is nothing but 2 pi minus pi by 4, adding 2 pi to this, so that will become 7 pi by 4 or same. Okay, what is the polar form? Root 2 cis 7 pi by 4 or minus pi by 4, same thing. But principal argument now cannot be 7 pi by 4, because once you are measuring this, you have crossed the real axis. You should not cross the real axis while measuring the principal argument. So principal argument can only be this, that is minus pi by 4. Let me emphasize here, principal argument is unique. Principal argument of a complex number is unique. However, the argument can have infinite number of values. If theta is one argument, then theta plus 2 pi is another argument, theta plus 4 pi, theta plus 100 pi, theta minus 100 pi, theta minus 200 pi. So the argument in general can have infinite number of values, but the principal argument is unique. Principal argument will be only one value, right? And now if you have understood this, just tell me what is the magnitude of this. So minus 1 minus 1, so this becomes, right? So what is the length of this? I'm quickly writing it root 2. So magnitude becomes root 2. Magnitude is always positive. Okay, you can just keep it in your mind that magnitude you cannot write as minus root 2, because magnitude is the distance, magnitude is the length. Length of what? Length of the vector joining from origin to the complex number, the length of this vector. So it doesn't matter where this vector lies in whatever quadrant, but the length will always be a positive number, a positive real number. Okay, root 2. Now what is the argument? Argument is, again, you have to measure it from the positive real axis. You have to measure it from the positive real axis. So either you measure this, if you measure this you will write in plus with plus sign, or you can also measure this if you do, then you will write in negative direction, with a negative sign, sorry. So what is this angle? So if you see in this triangle, this angle is pi by 4, okay, but pi by 4 cannot be the argument because argument is measured from positive real axis. So argument will become 5 pi by 4, 5 pi by 4, or minus 3 pi by 4, or minus 3 pi by, right, minus 3 pi by 4. What is the polar form? Root 2 cis 5 pi by 4 or minus 3 pi by 4, anything, doesn't matter, okay. And what is the principal argument? Again, principal argument cannot be 5 pi by 4. This cannot be the principal argument. Principal argument has to be, has to lie either from 0 to pi or 0 to minus pi. So this will be minus 3 pi by 4. It has to be unique. So this you have written, okay. I am giving you few complex numbers which you try it at home and let me know what is the answer. You tell me for 1 plus root 3i, root 3 plus I, okay. For these two complex numbers, you tell me what is the magnitude, you tell me what is the argument, you tell me what is the polar form, you tell me what is the principal argument. So these complex numbers in the left hand side, I have written it in Cartesian coordinate system and I have converted them into polar coordinate system, polar form. I am giving some complex numbers in polar form and would like you to convert it into Cartesian form. So let us say convert cis pi by 2. So this is polar form. You have to convert that into Cartesian form. Correct? Cis pi by 2, convert cis pi by 3, convert 5 cis pi by 6, convert 9 cis pi by 2, all into Cartesian form, and tell me what is the answer. Now the best part to look here is, if I want to find out the magnitude and argument in polar form, I can straight away write that magnitude of this complex number is 2, argument of this complex number is pi by 3, because this is written in polar form. Polar form will have argument and magnitude in its very explicit way. So what is the magnitude of this complex number? 5. What is the magnitude, what is the argument of this complex number? Pi by 6. So if I write what is the magnitude of cis alpha, cis alpha is multiplied by 1. So magnitude of cis alpha is 1. So any complex number, doesn't matter what is the argument, cis alpha will always have its magnitude as 1, right? And if I write what is the argument of cis alpha, then that is argument of, I will write r cis alpha, r cis alpha, that is equal to alpha, and magnitude of r cis alpha, that is equal to r, okay, because this is the polar form, this is the representation in magnitude and argument form. Okay, so this is the time to end the session. Just quick few things I will tell you. There is no meaning of inequality in complex number. So no meaning of inequality in complex numbers. So there is no Meaning, if I say Z1 is greater than Z2 has no meaning. Yes, but equality has meaning. So I can say Z1 equal to Z2 or Z1 not equal to Z3. They have meaning. We will see it in the next uh, discussion, next session. What is the meaning of having equality in complex number, and what is the meaning of having inequality in complex numbers. So this kind of statements have no meaning. They are absurd. They have no mathematical significance. Okay, so I will stop this session here, and we'll continue with few more fundamentals of complex number in the next class. Thank you.